Sorry about that. Here we go. Section 1.2, my bad. Conditionals and equivalent statements. So we're at truth table, equivalent statements. We got some more conditional situations or a conditional statement to look at. The conditional statement has a hypothesis, which is called your antecedent, and your conclusion, which is called your consequence. We're going to look at negations of conditional statements, whereas in 1.2 we looked at negations of just a single value. We're going to add in converse, inverse, and contrapositive, alternate forms, biconditionals, and just a summary of truth tables. So in this same thing, I'm just going to look at a couple examples. The other things are just notes for you to have. So there's those truth tables again. Once again, I'd probably put those on a note card and have those super handy near me. Those values will come in handy all the way along. So conditional statements are if-then statements. So if this, then that. So this is our hypothesis and conclusion type thing. Got our basic definition there. You can take a look at that, write that down, print this out how you want to do that. Excuse me. And so just kind of explaining the truth table real quickly. So P if Q is false when the antecedent, when the hypothesis is true and the consequence is false. If the antecedent is false, but the consequence is true, then it's automatically true. Let's see if, because you're coming out with the true statement, let's see if the consequence is true, and then you know that that point that at the end that no matter what, it's going to be true. So let's take a look at what that looks like. There's really only one scenario. I've got some words kind of help you sort through that. Only one scenario where this comes out to be a false statement. Whereas with our other truth tables, that wasn't the case with our our conjunction and disjunction. So conditionals can be written lots of different ways. We could say Q if P, just like if P then Q. We could say P implies Q, or when P then Q, or P if and only if Q, or only if Q. I'm sorry, I said it backwards. Yeah, P only if Q. So yeah, those are kind of some different forms here. So let's just jump into that. More statements, ways we can say that. These are great for your notes in case you come across it and you're just becoming familiar. We could do millions and millions of these problems to kind of get to a form of understanding, but we're just going to kind of brush through this stuff. Equivalent statements. So if two statements R and S have the same truth value in every possible situation, then we can say that R and S are equivalent. We can do that. We know that with conditional statements, this new thing we're going to introduce is the contrapositive, the converse, so contrapositive, the converse, and the inverse. We know that the conditional statement we're given, so if P then Q, is going to be equal to our contrapositive, and they're going to be equivalent, and we know that the converse and the inverse are going to be actually equivalent also. So what I did was I made a truth table just to kind of start exploring this, and then we'll kind of look at more in depth. So remember that when we make a truth table, we start off and we just, if this is what we're trying to get to, or this is what we're trying to get there, what we need to do is we need to be able to have the parts. So like this one has a negation in it, that one has a negation, so we have to do negations. This one right here, to be able to do that, I'm actually going to be, it looks like I actually don't have enough information. I'm going to need to add something in. So we'll just kind of fudge that here real quickly. All right, so let's take away this guy, and that means I'm going to need another column right here that's going to be my P, not P or Q. All right, so let's go across there. So not P, that would be false. Not Q, that would be false. Not P and not Q, that would be false. We're taking the false and false. And then P or Q, what's false, the negation of that. So we start off here, and this part is false, right? So P or Q, that would be a false, but we negate that, and that would make that a true. So we're taking this and negating it. All right, the next one, that would be false, that would be true. We put them together. So if it's an and, remember this is and, that's a conjunction. So since that's an and, then these both have to be true, so that's false. We come over here, we have P or Q. So P or Q, one of them is true, so that's true. But then we negate that and turn into false. Okay, the next one, we negate the first one, that's true. The second one, that's false. This is an and, so a true and a false. So that's going to be a false. On the next one, it's our disjunction. Remember, that one is called a disjunction. So that's an or statement. So if we're looking back at the original, we have a false or a true. So that's going to be true. But then we negate that true and we get a false. And then lastly, we go through here and we say false and false. That's true and true. So not P and not P. So that's a true and a true. That's that. Here we have a true or a false or a false. That's false. But then we negate that and we get a true. Now the question is, are these two statements equivalent? And the answer is no, because if they're equivalent, if this guy was equivalent to this guy, then their truth table would be the same all the way down. Oh, I did make a mistake. I just caught it. Sorry about that. Right here, I have a P or a Q. So I'm taking my true or my true. So that's actually going to be true. And I negate that and that'll become a false. So these two statements are equivalent because I have a false and a false. False, 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 true, true. So are these equivalent? And the answer is yes, based upon our truth table. So that was kind of like a jump in real quick. Let's kind of keep cruising along and see what else we come across. All right. So here's where we're going to formally introduce the converse, inverse, and contrapositive. So this is what they look like. So the conditional statement we start with is if P, then Q. The converse is if Q, then P. The inverse is the negation of P implies the negation of Q. And the contrapositive is the negation of the converse. So these two guys go together. They're the negation of each other. And then these two guys go together. They're the negation of each other. So what we're trying to do is establish equivalencies. So cruising on along. Here we go. So from this screen right here, what we'll do is we'll establish some congruencies. All right. So what I would probably do right now if I were you is I would hit pause in this video at this point. You've watched a couple truth tables and I would like go through and fill out what you can fill out. And if you get stuck, watch all the way up to that spot in the video and then fill in the gaps. All right. So go ahead and hit pause. All right. So welcome back. Hopefully you tried this out. You didn't have any problems. If not, watch it until the spot you're stuck. Then hit pause again and try to keep going. All right. And then that's the best way to understand these truth tables. So not P, so that's going to be false. Not Q, so that's going to be false. So P implies Q. Well, they're both false. And so we think about that. Let me grab so I'm looking at my notes right here. If they're both false, then that gives me, oops, my bad. I'm not looking at that. I'm looking at the original, right? So not P implies, so true implies true. So that's going to be true. Or Q implies P. So that's a true implies a true. So that's going to be true. Not P, so that's a false implies a false. According to my truth table, that's equal to true. And the last one is going to be not P, which is false, implies not Q implies not P, and that's going to be a true also. All right, next one. So I'm going to negate this first of all to kind of fill out my table. So that's going to be false. That's going to be true. On the first one, I'm doing a true to a false. So that's going to be a false statement according to my truth table. So what I have in front of me right now is I have the truth tables written out. So I'm looking at my note cards of a conditional statement. And I'm using my conditional statement rules to answer these spots. So now I'm going from Q to P. So I'm going from Q to P. So I'm going from a false to a true. I look at my truth table. A false going to a true is equal to a true. All right. On the next one, I have a false going to a true also. So not P goes to not Q. That's a true. And then I have not Q implies not P. And so that would be equal to a false. All right, keeping cruising along right here. So on the next one, not P would be, oops, let me change colors. Not P would be true, and that would be false. P implies Q, so P implies Q, that would be true. Q implies P, that would be false. Not P implies Q, that would be false. And not Q implies P, that would be true. Last one. So inverse or negation, negation. P implies Q would be true. Q implies P would be true. So Q implies P would be true. Not P, so that'd be a true implies true. That's going to be true. And not Q implies not P, and that's going to be true. So we're looking for equivalency right here. So let's see. So I have true, false, true, true. True, true, false, true. True, true, false, true. So true, true. So this guy right here and this guy right here are equivalent to each other. And then we have true, true, false, true. True, false, true, true. Oh, I made a mistake someplace. Oh, I just circled the wrong one. My bad. That's the worst part about this is that if I have to delete something, I have to clear the whole thing. So I apologize for that mistake. So this is our statement. So our statement is logically equivalent to this guy. And that guy right there is called our contrapositive. And then we have these two guys. So true, true, false, true, and true, true, false, true. Sorry about that. I'm trying to get this to move for me. There we go. And that's my converse and my inverse. So then I have my converse and my inverse are each are logically equivalent. All right, so filling out my truth tables, go ahead and hit pause, like I said, come back to that one, practice that a couple of times. That's what you're going to be doing in your homework is kind of completing truth tables like that to look for equivalencies and kind of answer some questions. Got a couple more examples here for you to read through and use. For examples, we have a thing called De Morgan's Law. And in De Morgan's Law, where we're just kind of like working through, they've kind of already proved it. So you don't have to like prove it. For any statements P and Q, these guys will always be the same. And you can kind of think about this as like a distributive property in some ways. So like, for example, you think about it, like you're distributing the negation through. So you got P or Q. So not P, but instead of being or becomes and, not Q. Or vice versa. The conjunction becomes a disjunction when so what we're looking at here is this relationship between conjunctions and disjunctions. And you don't have to prove that. If you come across someplace and like they have this, then you can automatically answer this with that. You know that those are going to give you the same answers is the idea. So, I mean, you can play around with it and prove it for yourself, like so to make sure, but you can apply the De Morgan's Law in any case. And we got some examples of that. And then we have negations of statements, of conditional statements. So kind of the same thing. So once you go ahead and like whether you have this printed out or however you're going to work it, is just kind of proving out like these conditional statements are true of each other. And so I'm going to go ahead and work it out. You can go ahead and like hit pause, try it yourself, and then come back and fill it in. All right. So remember, you'll go true, true, false, false, true, false, true, false. So we negate this. So we're trying to build out, we have to have a negation of a Q, and we have to have, in this one right here, we have to have a P implies Q. Did I already work this one? Let me go take a look real quick. I feel like I did at the beginning. Yep, there it is right there. Not P and not Q. Nope, it's slightly different. So we negate the Q, that gives us false. Oops, sorry about that. We negate the Q, That gives us false, false. Oh my God. Sorry. Clear selection. I have a new tablet coming, so this will hopefully help with my video recordings. So true, true, false, false, true, false, true, false. We negate the Q. That would give me false. That would give me true. That would give me false. That would give me true. Now we do P and not Q. So we're looking at P and not Q. So one's true, one's false. That's false. One's true, the second one's true, that's true. False and false, they're both false, so it's false. False and true, that would be false also. We do P implies Q, so now we're looking at P and Q there. So that would be true, that would be false, that would be true, and that would be true. Then we negate that, so we take this statement and negate it, and we get false, true, false, false. Okay, the question is are these two statements, are we trying to prove that they are equivalent to each other? So we just prove that this statement right here and this statement right here are logically equivalent. All right, cruising right along. Oops, let's go ahead and clear that. Cruising right along. We have biconditional statements. So those are if and only ifs. They go both ways. So P implies Q and Q implies B, or P, excuse me. And so biconditional is just saying like, it can go either way to get to that spot. And so just to kind of prove that it works, we have this truth table we can plug in here. So P implies Q is true. Just set up so you can see it. And all these are just like me proving that this actually works. I mean, that's what this really comes down to, is just proving that these actually have an agreement here. So P implies Q, so P implies Q is true. P implies true, that's false. P implies true, that would be true. And a false implies a false gives me a true also. We go the other way. So true and true gives me true. False to true gives me a true. Let's see. True to a false gives me a false, and a false and a false gives me a true. So now we're going to go through there and kind of show that goes both ways. So in this case right here, we would have, that would be a true and a true gives me a true. This would give me a false and a true. Sorry about that. And that's equal to a false. Not supposed to be an A, right? There's supposed to be a hat. A true and a false will give me a false. And a true gives me a true. So what we just did is a little proof to show why those have those values. So once again, that's another. So you would take and pull out your notes and put that on your note card. So you have a biconditional statement right here. So now we know that if we have a biconditional, that would be our truth values coming out of that. Two trues give you a true. One true and a false give you a false. One false and a true give you a false. And two falses give you a true. So some examples to take a look at. Some or statements. A tautology is a statement that is always true, no matter the truth values of the component. It's called a tautology. And so we don't have an example of that right now. I just want to put that in your notes. And then we got a little summary of the truth tables, and that should wrap us up for section 1.2.